Hey guys, welcome back to the continuation of the chapter of organic chemistry, which we have started already, and we are done with few of the concepts. In the previous concepts, we have discussed what is organic chemistry and what are the hydrocarbons, as well as we have started the topic of alkanes, properties, physical properties of alkanes have been studied. What are homologous series? What is the functional group? What is the general formula? What is the combustion property of an alkane, and what is the cracking for alkanes, along with substitution reactions of alkanes are done as well. Right now, today we are going to start a very new concept, and that is called alkenes. It is basically an other homologous series. You may say this is the second homologous homologous series which we are going to start today, inshallah. Okay. In case of alkenes, if we are focusing on the basic concept of alkenes, a student should know this thing, that there must be at least one carbon carbon double covalent bond in an alkene. Okay, so consider this compound. It has one, two, three, four, five, six, seven. Okay, we can say this thing that seven carbon atoms are bonded with each other through single covalent bond. Hence, due to absence of carbon carbon double covalent bond, we will consider it as an alkane. But now, for example, 1, 2, 3, 4, 5, 6, and 7. Out of all these seven carbon atoms, there are two carbon atoms which are attached with a double covalent bond. We can say this thing that all of the seven carbon atoms are attached with each other through single covalent bond, except one carbon carbon double bond is there. So carbon number 3 and carbon number 4 are attached with a double covalent bond. What is the meaning of carbon number 2 and carbon number 3 and 4? Just start counting from this side, for example. Guys, what is counting and why we are requiring this counting of carbon atoms? Guys, this will be important regarding naming of an organic compound. I will discuss the naming of organic compounds specifically, separately, as a separate specific topic. So right now, for example, if I am saying that this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, number 6, and number 7. Can we say it that carbon number 3 and 4 are attached with a double covalent bond? Hence, we are considering the second one. This is, for example, this is A compound and this is compound B. The second one is compound B. Okay. So we can say this thing that compound B is considered as an alkene. And why it is so? Because it has a carbon-carbon double covalent bond. So for example, if there is a carbon chain of 100 carbon atoms, what is the meaning of the term carbon chain? Guys, in the B case, you can say this thing, and in the A case as well, that there are two carbon chains. One is A and the other is B. What is the meaning of carbon chain? When carbon atoms are attached with each other either through a single covalent bond or through a double covalent bond or through a triple covalent bond. Yes, there is a triple covalent bond as well, but that triple covalent bond is not part of your syllabus. I will give you a hint. I will give you a little bit description about carbon carbon triple covalent bond as well. Sometimes examiner is giving such type of concepts, but telling the information about those concepts, he can ask some analytical questions, he can ask some questions which are related to that information which he has shared with you. So instead of giving you that as a mystery, I'm going to tell you a small information about carbon carbon triple covalent bond as well, inshallah. Okay, right now I am telling you what is carbon carbon atoms making chain thingy. What is that chain process? Okay, guys, before moving ahead, I would like to bring your attention towards a term that is called as catenation. Okay, now what is that catenation? Catenation is a process in which carbon atoms are attached with each other through a single covalent bond or through a double covalent bond or through a triple covalent bond. So we can say this thing that catenation is a process in which carbon atoms are attached with each other. They are making a chain. That process is called catenation. Okay. So here in A and in B, we can say this thing that in A, 7 carbon atom chain is there. It means that 7 carbon atoms are attached with each other. In B, 7 carbon atoms as well, and they are attached with each other as well. But there is a difference between A and B. And what is that difference? In case of A, there is no carbon-carbon double covalent bond, whereas in B, there is one carbon-carbon double covalent bond. We will consider it like this. We will say it that carbon-carbon single covalent bonds are there in A. Hence, A will be considered as an alkane. Whereas there is only one carbon-carbon double covalent bond in B, that one carbon-carbon double covalent bond is making it an alkene. Okay, an alkene. So I am writing here very clearly that B is an alkene. Okay, now I am going to change the page right now. We can say this thing that in case of alkenes, for example, if we have like this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, so how many carbon atoms are there in this carbon chain? 22. Is this a chain? Yes, this is a chain. Why? Because 22 carbon atoms are attached with each other, making a chain type of a structure. Okay. Out of all these, there are only 2 carbon atoms which are attached through a double bond. Okay. So in which category we are going to keep this chain? We are going to keep this chain into a category of alkene, an alkene. Okay. So I'm writing here alkene. Okay. Why it is considered as an alkene? Due to the presence of carbon-carbon double covalent bond. So guys, I would like to bring your attention to this point that either it is a small carbon atom chain or it is a longer carbon atom chain. But if there is only one carbon-carbon double covalent bond, that is sufficient to change the category of that hydrocarbon from an alkane to an alkene. So you are not going to say this thing that it has 22 carbon atoms. Out of these, only 2 are attached with a double covalent bond. Will we consider it as an alkane? No, we are not going to consider it as an alkane. It is now an alkene. It is now an alkene. So this is the basic concept related to the difference between an alkane and an alkene. Guys, I'm going to change the page right now. There is a term which is called as saturated hydrocarbons. Saturated hydrocarbons. And the other is unsaturated hydrocarbons. Okay. Saturated hydrocarbons and unsaturated hydrocarbons. These are the two terms which are really very important regarding paper point of views. Guys, let me inform it to you very clearly. Saturated hydrocarbons are alkanes only, whereas unsaturated hydrocarbons are alkenes and alkynes as well. What are alkenes? Those compounds having at least one carbon-carbon double covalent bond. What are alkynes? Which have at least one carbon-carbon triple covalent bond. So here I am going to write carbon-carbon single covalent bond, carbon-carbon double covalent bond, carbon-carbon triple covalent bond. Guys, you can see this thing that A is a compound which has only one carbon-carbon single covalent bond, hence it will be considered as a saturated hydrocarbon. B has carbon-carbon double covalent bond, that's why it will be considered as an unsaturated hydrocarbon. C has a double covalent bond as well. Here I am going to write C. C has a triple covalent bond and it is also unsaturated. So here I am writing very clearly Both of these are unsaturated, whereas A is considered as saturated hydrocarbon. Okay, so only those compounds which have carbon-carbon single covalent bond, they are considered as saturated hydrocarbons. Guys, let me explain it to you again with another point of view. Sometimes in some of the organic compounds, there might be a carbon oxygen double bond. Sometimes in some of the organic compounds, there might be carbon nitrogen double covalent bond or carbon nitrogen triple covalent bond. Sometimes there can be a compound in which carbon is making a double covalent bond with some other elements like oxygen and like nitrogen I have mentioned. Sometimes it is a possibility with you may consider some of the elements from group number 6 and 5 as well, which have the ability to make more than single covalent bond with carbon. So in those compounds, as far as carbon carbon double covalent bond is not present, we are not going to consider it as unsaturated hydrocarbon. I'm going to shift you to the next page and going to give you some examples so that this concept may be clarified further. Okay. So right now we can say this thing that, for example, there is this compound like this. Okay, you can see this thing. And this will be considered as saturated. Okay, please be careful. Okay, why? Because this compound has only carbon-carbon single covalent bond. And this is not making it unsaturated, not making it unsaturated. So it is what? It is saturated hydrocarbon. Okay, now for example, a compound like this, okay, is there, and this is C and C and C, and this is C and C. Okay, now there is a double covalent bond, but that double covalent bond is between carbon and nitrogen. That's why we are going to consider it as a saturated hydrocarbon. So again and again, I'm repeating my words that this is just carbon-carbon double covalent bond which is responsible for the unsaturation. So as far as only carbon-carbon single covalent bonds are there, the compound is considered as saturated. But if there is only one carbon-carbon double covalent bond will be there, it will be considered as unsaturated hydrocarbon. So for today's lecture, it should be very clear that alkenes are those compounds which have carbon-carbon double covalent bond. At least one carbon-carbon double covalent bond is sufficient to shift the homologous series from the alkanes to the alkenes. So if there is a longer carbon atom chain, but only one carbon-carbon double bond is there, that is sufficient to shift the series from alkanes to alkenes. If there is carbon-carbon double covalent bond present, it is alkenes. I'm repeating my words. But for example, if there is a double covalent bond between oxygen and carbon or nitrogen and carbon, even then that is remains saturated hydrocarbon. Okay. So there is a test for the compounds saturated and unsaturated hydrocarbons. There is a test of identification between carbon-carbon double covalent bonds and carbon-carbon single covalent bond, that is called as a saturation test. Inshallah, in the next class, we are going to share this saturation test. All the best to all of you.